A place already under threat is California's iconic coastline. California and the West Coast have been hit by El Niño storms, which is called "This is the Impact." These massive cracks in the earth, this popular scenic trail, a sudden and unsettling change swept across a stretch of America's coastline, sparking both alarm and fascination. Residents woke to discover a jagged crack where solid ground once stood, their peaceful shores now marred by a sharp rupture that seemed to appear out of nowhere. Though earthquakes are not uncommon in certain regions, this abrupt fracturing raised countless questions. Why here, and why now? Could this be a warning sign of deeper tectonic shifts lurking beneath the surface? In this exploration, we journey through the hidden forces that shape our planet, some slow and nearly invisible, others explosive and catastrophic. We'll delve into the possibility of ancient rifts that never fully closed, the quiet menace of underground fires that burned for centuries, and the staggering might of volcanoes, whether they are ocean-bound or shrouded beneath polar ice. Along the way, we'll consider how subtle ground movements can lead to dramatic ruptures, upend communities, and remind us of nature's unwavering capacity to surprise. Our story will connect seemingly distant phenomena, an inland quake that reshaped rivers, a coastal crack that caught everyone off guard, and volcanic regions where molten rock seethes just beneath our feet. By weaving in personal anecdotes, rhetorical questions, and real-world examples, we aim to illuminate the tensions hidden below Earth's crust. Ultimately, we'll ask how these events might be intertwined and whether they foreshadow greater upheavals to come. So, settle in and prepare to discover how the Earth beneath us is both steadfast and ever-changing, and why one sudden crack in the coastline might only be the beginning of a much larger saga. The sudden fracture along the shore took a startling turn when local residents noticed deep fissures spreading along the coastline. It was as if a colossal hand had torn the ground, leaving behind an unsettling reminder that the Earth is never truly at rest. While some quakes are heralded by rumbling shakes and dramatic jolts, this rupture emerged with relative silence, an almost stealthy appearance that defied typical expectations. Concerned citizens rushed to take photos, capturing the fractured shoreline jutting awkwardly toward the sea. The puzzle lies in understanding how something so significant could unfold so quietly. Underlying pressures in the Earth's crust often accumulate over decades or centuries, only to release in sudden bursts. In some cases, a locked portion of a fault reaches its tipping point, forcing the land to give way. Unlike the well-known scenario of a single powerful jolt, a slow build-up can result in cracks that seem to manifest out of thin air. This kind of gradual strain might generate minor trembling that goes unnoticed, until finally, the surface decides it can no longer hold together. One might draw parallels to a tightly coiled spring. Even if the movement is imperceptible, the tension persists. When that spring is released, it can snap violently or unwind in a quieter but no less remarkable fashion. A coastal zone perched at the boundary between land and sea may amplify this effect. The constant push and pull from tides, shifting sediments, and even subtle temperature changes can enhance existing weaknesses in the rock. The unsettling image of a once pristine beach now split apart stirs up urgent questions. Could larger quakes or additional fractures follow? Will the nearby ocean intrude into these cracks, accelerating erosion or even reshaping the local shoreline entirely? In this sudden fracture, we glimpse not just a local mystery but a broader window into the planet's underlying tensions, and a reminder that our landscapes can transform overnight. Echoes from an ancient inland quake long ago tell a similar story. A massive quake rocked the interior of the continent, affecting a vast area where most people assumed the land was stable. Stories passed down through generations describe rivers flowing in reverse for a short time and lakes forming where there had been none before. Though details have grown hazy with age, the underlying lesson remains: enormous geological forces do not limit themselves to well-known seismic zones. Why bring up an ancient inland quake when focusing on a recent coastal fracture? The link lies in the concept of stored stress. The continent is crisscrossed by older rifts and faults, some visible, others buried beneath layers of sediment. Even when a fault line appears dormant, it may conceal the remnants of past upheaval. Pressure can linger for centuries, only revealing itself in a sudden event. If a fracture opens along the coast, it might shift the tectonic balance just enough to awaken stress in places thought to be inactive. This contradiction, quiet landscapes masking dormant potency, demonstrates that we often underestimate the potential for surprise. Even if the coastline draws our gaze due to its dramatic rupture, the lessons from the inland quake caution us that tectonic stress can travel. We might think of the continent as a single, interconnected puzzle. When one piece shifts, the rest can bear altered pressure. It's possible that a fracture along the shore could, in some subtle way, redistribute stresses that eventually trigger movement elsewhere, or simply signaling that deeper changes are underway. In remembering that ancient inland quake, we also realize the importance of collective memory. A single generation may overlook minor tremors or rising cracks, but if we trace the region's entire history, patterns of activity become clearer. This is where the inland quake resonates. It serves as a testament that quiet faults can produce huge results, even when time seems to have lulled them into dormancy. When earthquakes unfold in slow motion. Typically, earthquakes are imagined as abrupt, jolting events that last mere seconds. Yet, there is a slower form of seismic activity lurking beneath our feet, one that doesn't always register as a violent shake but can still dramatically reshape the land. Known in some circles as slow slip events, these drawn-out movements can stretch over weeks, months, or even longer, creating almost imperceptible shifts until something finally gives way. Imagine a grand tug-of-war where one side very gradually yields over time. Tension spreads to more rigid sections of the fault, raising the possibility of sudden fractures once the stress threshold is reached. These slow-slip episodes can creep along nearly unnoticed, allowing pressure to accumulate in adjacent regions. When the tension finally finds release, it can lead to an event that appears shockingly abrupt, like the recent rupture along the coast. Contradictions abound in such scenarios. On one hand, the ground is in motion for an extended period, yet people might remain blissfully unaware since there's no strong jolt. On the other hand, a subtle process can pave the way for a forceful outcome, drawing parallels to how a small leak in a dam can ultimately contribute to a catastrophic breach. That's why many are beginning to pay closer attention to gradual ground changes, especially in tectonically complex zones. One anecdote recounts a farmer, far from any known quake zone, who noticed a slight tilt in his barn's foundation long before any rattling was felt. Only later did he learn that a slow slip event had been nudging the land, transferring stress across a broad region. In similar fashion, the cracks that appeared along the coast could be the final flourish of a storyline set in motion months or years beforehand. Despite the gentle build-up, the end result can be sudden, visible, and dramatic. Forgotten rifts beneath quiet terrain. Across seemingly tranquil plains and valleys, there exist ancient rifts that never fully evolved into major plate boundaries but still scar the Earth's crust. These hidden fractures can extend for hundreds of miles, now covered by river sediment, farmland, or urban sprawl. For generations, inhabitants might have remained unaware of any geological risk until a sudden jolt or a gradual splitting reveals the deeper instability beneath their feet. These old rifts can linger in a kind of geological limbo. Even though they are no longer actively ripping continents apart, they haven't vanished. Under certain conditions, stress can accumulate along these weak zones. Picture a fault line lying dormant, layered under thick deposits, yet retaining the capacity to release energy when prodded by broader tectonic forces. The abrupt coastal fracture might be an echo of this phenomenon, as shifting stresses migrate from one region to another, exposing weaknesses long considered inactive. Comparisons with other areas of the world show similar surprises. In regions far from known plate boundaries, towns have experienced sudden ground ruptures with minimal warning. That's a stark reminder that safety from seismic events often hinges on incomplete assumptions about where the big faults are, or are not. One might say the Earth's old scars never truly heal, they just rest for a while. Consider a personal story. A homeowner living on flat ground begins to notice cracks in the driveway that grow steadily wider each year. At first, these are dismissed as simple settling. Then, a nearby stream shifts course during a particularly wet season, and the cracks expand drastically. Only after consulting experts does the homeowner learn that an ancient rift runs beneath the area. This experience underscores how the Earth's crust can be riddled with half-buried stories of upheaval. Sometimes, all it takes is a broader tectonic adjustment, a nudge, to bring these forgotten fractures roaring back to life. The unseen fires that shape the land. Amid the fascination with quakes and fractures, there's another, less obvious force altering the surface: underground fires that smolder continuously in coal seams. This phenomenon can persist for decades or even centuries, gnawing away at buried fuel and gradually reshaping the overlying terrain. Unlike a raging wildfire that consumes forests with visible flames, these subterranean blazes burn slowly, feeding on pockets of coal and creating hollow cavities. While it may seem unrelated to the sudden crack along a coastline, such fires remind us that the Earth can undergo hidden transformations that remain invisible until the surface gives way. Over time, the heat generated by these underground infernos weakens rock structures and soil, causing sinkholes or ground collapses. Imagine an entire hillside that gradually sinks or caves in, all because of a fire no one can see or hear. If enough land slumps, it can form fissures that spread outward, connect to existing cracks or faults in unexpected ways. A subtle parallel exists between these fires and slow-slip events. Both involve processes that unfold over long periods, often without dramatic early warnings. One personal anecdote describes a remote village where ground temperatures spiked unexpectedly, singeing plant roots and wilting crops. When a cautious villager dug down, they discovered a slow-burning coal seam. For them, it was a revelation that not all natural dangers arrive in a thunderous quake or a towering flame. These underground fires are notoriously difficult to extinguish. Flooding the affected zone, pumping inert gases, or isolating the fire with trenches are tried approaches, yet success is far from guaranteed. Meanwhile, the landscape above continues to morph as the smoldering front moves. Just as the coastline split without a grand announcement, so too can an unseen coal seam fire gradually carve its mark on the Earth's surface, underscoring the endless variety of forces shaping our planet. Volcanic threats and their worldwide impact. While earthquakes and underground fires offer one lens into Earth's power, volcanoes provide another dramatic view. Some stand as majestic mountainous cones that erupt with explosive force, whereas others are wide shield volcanoes quietly oozing rivers of lava. Regardless of the form they take, volcanoes illustrate the profound link between tectonic movements and the molten heart of our planet. An eruption can transform an entire region in a matter of days, burying landscapes under ash, forcing mass evacuations, and occasionally affecting global weather patterns by injecting vast amounts of particles into the atmosphere. How might a coastal fracture tie into volcanic activity? Though they may seem unrelated, both can arise from shifting tectonic plates. A fracture on land can be part of a larger chain of geological adjustments. In some volcanic arcs, stress changes along plate boundaries can trigger a volcanic awakening. Likewise, volcanic intrusions can place added tension on nearby faults, paving the way for sudden splits in the surface. It's a complex interplay where each movement can ripple outward in unexpected ways. Personal stories from those living near active volcanoes often highlight this interconnectedness. One traveler recalls being woken by a tremor in a place known primarily for its scenic beauty. In the following days, a nearby volcano began showing signs of unrest, belching steam and small amounts of ash into the sky. Though the quake and volcanic activity weren't definitively linked, many suspected that the region's shifting stress contributed to both events. Draw comparisons, too, with other nations situated on volatile fault lines. Along certain coasts, seismic shifts and volcanic outbursts go hand in hand, forcing residents to adapt to a life of frequent geological surprises. The recent coastal tear in the United States could well be one more illustration of how the Earth's internal pressures manifest at the surface, reminding us that what happens beneath the crust can affect people's lives thousands of miles away. Buried volcanoes under ice and snow. High latitudes covered with thick ice are often imagined as still, silent realms, but beneath that icy facade lie hidden volcanoes capable of changing entire landscapes. These subglacial volcanoes can remain sealed off from direct observation by a massive sheet of ice, complicating attempts to detect their activity. When a volcano smolders below the surface, heat transfer through the ice can create vast meltwater channels, subglacial lakes, or destabilized ice shelves, all with potential repercussions for global sea levels. Drawing a line back to the fractured coastline, the lesson is that immense geological forces can hide in places we least expect. Just as the coastal split arrived with minimal fanfare, a subglacial eruption might quietly reshape the ice from below, until something dramatic happens, like a large outburst flood tearing through the glacier's front. While the two phenomena differ in visuals, both underscore our planet's capacity for concealed, powerful movements. It's revealing to compare these hidden polar volcanoes with the more famous fiery peaks near tropical zones or continental rifts. In warm climates, volcanic activity announces itself with visible gas plumes, roaring lava fountains, and quaking ground. Subglacial volcanoes, on the other hand, release their energy through melting and fracturing ice. The interior meltdown can evolve into an external crisis if the meltwater suddenly drains or if the ice above collapses, akin to a pressure valve blowing open at an unexpected time. One explorer anecdote recounts hearing dull booms echo under a glacier. While uncertain of the cause, they later learned that a subglacial eruption had produced steam explosions deep under the ice. The event never manifested in a classical volcanic sense, no towering ash cloud or pyroclastic flow, yet it left cracks and crevasses across the surface. These hidden processes again highlight that Earth's drama is not always loud or visible, and sometimes the biggest transformations occur behind a veil of ice or beneath an outwardly calm coastline. Massive magma chambers, myths and realities. Deep underground, in certain volcanic regions, lie reservoirs of molten rock so vast they can span across entire counties. Such magma chambers feed geysers, hot springs, and other geothermal wonders. At the surface, some fear that these colossal pockets might erupt in cataclysmic fashion at any moment, pointing to past events that darkened skies and reshaped continents. While stories of overdue super-eruptions persist, the reality is more nuanced. Schedules and pressure dynamics within these chambers can evolve over unimaginable spans of time. Consider how this ties into a coastline suddenly breaking open. Both phenomena stem from immense subterranean energy. Whether that energy manifests as a fault rupture or a volcanic blast depends on many factors: rock composition, local stress fields, and even the presence of water or ice. In some areas, the crust might accumulate stress for an age without any surface sign, only to snap in an instant. Similarly, a magma chamber can lurk underground, building heat and pressure that may or may not find release in our lifetimes. Comparisons arise when looking at other parts of the world with large, active magma systems. Some have frequent minor eruptions that ease pressure bit by bit, while others remain eerily silent, raising speculation about a future super-eruption. One traveler recounts walking across terrain famous for steaming vents, where the ground felt warm underfoot and the air reeked of sulfur. The experience was equal parts awe and apprehension, a reminder that below the crust are processes of incalculable scale. The concept of inevitability, whether for a massive volcanic event or another coastal fracture, often comes down to geological memory. We know these massive changes have happened before. The question is never if, but when. Recognizing that our planet's timetable may vastly exceed our own fosters both humility and vigilance in the face of these colossal forces. Aftershocks, chain reactions, and the road ahead. When land unexpectedly splits, the repercussions can echo far beyond the immediate coastline. A fault shift in one area could redistribute stress to another, sometimes many miles away. This raises the specter of a chain reaction. One rupture may not only alter the landscape but also set the stage for further seismic events in adjacent regions. For coastal communities, there's the added complexity of interacting with the sea itself. Changes in land elevation might allow water to flood new areas or tilt the local shoreline, modifying the shape of beaches and inlets. Such transformations prompt questions about safety and planning. Could more fractures appear without warning, potentially damaging infrastructure or displacing entire neighborhoods? The memory of an unforeseen crack lingers, spurring both public debate and personal reflection. Some might respond by reinforcing buildings, revisiting evacuation routes, or even considering whether to move farther inland. Others may place hope in technology, from seafloor sensors to advanced satellite imaging, hoping to detect early signs of a looming rupture. Parallels can be drawn to other nations where multiple fault segments occasionally slip in quick succession, magnifying the impact of each event. It's reminiscent of a line of dominoes: push one, and the rest may topple in surprising ways. A personal anecdote involves a coastal farmer who woke to find seawater seeping through a new fissure near his fields. Although the quake that caused it was minor, the subsequent flow of water eroded the land, making the crack wider and jeopardizing his crops. These incidents underscore the interconnectedness of Earth's systems. One event can cascade into another, linking everything from inland rifts to subterranean fires to oceanic dynamics. While no one can predict every twist and turn, understanding that chain reactions are possible may help communities brace for surprises. The fractured shore may serve as both a warning and an opportunity, a reminder that the future is shaped by forces that, at times, remain stubbornly beyond our control. We've journeyed through a landscape of interwoven geological phenomena, sudden fractures by the sea, dormant faults in quiet plains, slow slip events unfolding in stealth, and volcanic wonders hidden under ice. Each tale underscores our planet's capacity for both gradual transformations and shocking upheavals. While the coastline's dramatic split initially captured our focus, the bigger narrative is that Earth's crust holds countless secrets waiting to emerge. Leave a comment below and let us know which discovery amazed you the most. Do you think there are more Ice Age fossils or hidden caves still waiting to be found? We'd love to hear your thoughts and theories. Don't forget to like, share, and subscribe to stay updated on more amazing discoveries and hidden wonders from around the world. Hit the bell icon so you won't miss our next adventure.